Hi everybody, welcome to today's edition of HDInsight Deep Dive. My name is Rashim Gupta and I'm a Principal Program Manager here in the HDInsight team. And today we will talk about how to do Hive programming on the HDInsight platform. This is one of many sessions that the HDInsight team is doing to help you get a better understanding of HDInsight and how to develop big data apps using Azure HDInsight. So with that, let's get started. So in today's talk, here's the agenda that we will talk about. We will start by discussing essentials of Hive, what is Hive, why we need it, and a little bit more details into Hive. We'll next look at the architecture of Hive to understand Hive better and how it fits in within the Hadoop platform. We'll next compare Hive with relational databases, and we'll spend the bulk of the time with Hive programming. My goal is to have a few demos to give you a more practical insight as to how Hive works. So with that, let's get going. Let's first deep dive into Hive essentials. So before we discuss Hive, let's take a step back and look at the Hadoop offerings within Microsoft Azure stack. So at a high level, when we talk about providing you a platform for big data, we look at two parts, analytics and storage. Let's start bottom up. At the lowest layer, storage, typically if you're coming from on-prem, your Hadoop cluster provides you the storage, which is the local storage that is provided in your cluster. So the same disks that are used, so the same nodes that are used in your cluster, the local disks in that cluster provide storage. So on the cloud, we actually break storage separately than compute. So what that means is the nodes that you run are only used for compute, and for storage you use typically a storage service, a network storage, like in our case it could be cloud storage like Azure Blob or Azure Data Lake storage. Okay, so going back, for storage you have a bunch of options. You could either use your local storage like on-prem, which is your HDFS, or you could use the cloud HDFS, which is Azure Blob or Azure Data Lake Store. So that's the storage part. That's this bottom part. Now let's go on top. On top, there are two choices you have. You can either use infrastructure as a service, which is the right part, which I'm highlighting here. In infrastructure as a service, you go to our marketplace and you deploy your favorite vendor's bits on Azure VMs. So the only difference is, instead of running Hadoop on your on-prem nodes, you would run Hadoop on the Azure VMs. You would still be responsible for choosing the vendor, choosing the right bits, upgrading, patching. Your support contract would be directly with one of your Hadoop vendors. So this is more, in this case, it's more heavy weightlifting on your part because you will have to manage your Hadoop cluster. The other choice is HDInsight, which is platform as a service. What is HDInsight? HDInsight allows you to run Hortonworks bits. So we actually partner with Hortonworks builds, certify them in Azure, and deploy them directly on Azure VM. So when you come in, you just press a button and say, I want to use a 20-node HDInsight cluster, and we take care of provisioning those 20 VMs for you, making sure the bits are installed in all 20. So after a few minutes, you are just good to go, and you can just start running Hadoop jobs. So you don't have to worry about deploying your cluster configuration, things like that. We've taken care of that for you. So now that we understand a little bit, so we highly recommend using HDInsight because it makes you more productive and you can start using Hadoop right away. With that, let's talk about HDInsight. What is HDInsight? HDInsight is Hadoop and Spark as a service on Azure. It's, as I mentioned, it's fully managed Hadoop and Spark built for Azure. We take care of deploying the bits for you, and you can just go ahead and use it. It's 100% open source, based on Hortonworks data platform. So while if you are using Hortonworks or for that matter Cloudera or any other open source Hadoop, it'll just work on HDInsight. It's 100% open source. We even contribute back to open source. The next thing is clusters are up and running in minutes. So as I mentioned before, you don't, once you press a button, you don't have to worry about having buying the VMs or anything. You just press a button and we deploy the VMs, we deploy the bits in it, and you're good to go. In about 20 minutes, you're good to submit your first Hadoop job. It is supported by Microsoft with industry's best SLA. The next, familiar BI tools for analysis. Not only do we help with deploying Hadoop, but we also do a lot of tooling work, which is especially great if you are in the Azure ecosystem. Out of box, we work with Visual Studio, IntelliJ, and Eclipse. We also work with notebooks, both Zeppelin and Jupyter, and we also have an ODBC driver, which you can use to work with Excel, Tableau, Power BI, or your favorite BI tool. And finally, according to a study done, using cloud is up to 63% cheaper than using Hadoop on-prem. So based on that, HDInsight is really a good choice to do Hadoop on the cloud. So when we say HDInsight, what is what is it that we're offering? So when you look at the HDInsight stack, you choose from one of the different clusters. These are the different cluster types we have right now. We have batch Hadoop, interactive Hadoop, streaming, NoSQL, Spark, and ML. So the difference between if you're coming from on-prem or a different Hadoop vendor, typically you get all of these in one package together. The way HDInsight works is we actually break it into separate cluster types. The advantage of that is we can optimize for a particular scenario. So customers who typically want to use Storm, if they pick a Storm cluster, which is this one right here, so if they pick a Storm cluster, the entire cluster is completely configured for Storm. So they don't have to waste resources for Hive or Hadoop or Spark or ML if that's not what they plan to use. So that's one of the advantages. The other advantages is because we break away compute and storage separately, you can always have two clusters talking to the same storage layer and the same metastore, as long as that metastore is a persistent metastore, and they're able to talk to each other. So for example, I could spin up a batch Hadoop and a HBase cluster, both of them talking to the same storage account and the same metastore account, and with that, now they're able to communicate with each other and behave as if it was one cluster. So this architecture enables a lot of interesting scenarios. So like I mentioned, there are different cluster types we offer. We have the batch Hadoop, which you can use to run Hive, MapReduce. Typically customers use this for our ETL workloads. We also just released an interactive Hive cluster. What you can do if you want to use in-memory caching for Hive for more data science BI scenarios, you can use that. And again, these two can work together. Again, as long as they share the same storage account. So the output of this ETL job can be written to a storage account, which can then be read by this interactive Hive cluster. We also offer for streaming, we offer Storm. For NoSQL, we offer HBase. We have a Spark cluster, which offers Spark ML and Spark SQL. And then we have an ML cluster for our server. All of these run on the Yarn Resource Manager, which together runs on HDFS. As I mentioned before, HDFS can be a local disk on the VMs, but we recommend using actually the cloud storage, which can be Azure Blob Storage or Azure Data Lake Storage. So again, HDInsight allows you to choose from a range of Hadoop compatible tools. It allows you to run intensive apps such as HBase and Storm on a separate cluster. And finally, it ensures better ROI by checking query results. Now that we've talked about the HDInsight stack, in today's session, we're going to focus on the batch Hadoop, primarily on Hive, which you can use in batch Hadoop or the interactive Hive cluster. So let's talk about why we even need Hive. So let's take a step back. So when Hadoop was initially introduced, MapReduce was the primary language of choice. What is MapReduce? MapReduce is a framework, is a programming and runtime framework that allows you to analyze huge data sets in HDFS. It's designed to let you write applications that process vast amounts of data in parallel or a large cluster of compute nodes. These nodes are typically very off-the-shelf hardware. So it's very cheap hardware, and so it's easier. The goal of Hadoop is to scale out instead of scale up. So a user would typically supply a map and a reduce function, where the map function would typically parallelly read the input data, build key value pairs, and pass these key value pairs to the reduce. And the reducer would take these key value pairs and do combine it or reduce it and create the final output. So this is how MapReduce used to work. The only problem was MapReduce was it used to take a long time to write even a simple, even writing a word count would be like 100 lines of code in MapReduce, right? So it was very steep learning curve. And so that's why Hive was introduced. Hive was actually introduced by Facebook around 2005, 2006. And Hive is a data warehouse system for Hadoop. It is not a relational database. So that's one of the key things to remember. It's just a language which allows you to talk to Hadoop. Also, while it's not a relational database, it maintains the metadata information in a metadata store. In HDInsight, we use the Azure SQL DB as this metadata store. Hive treats your big data like tables and SQL-like operators. So if you know, and it uses a scripting language called HiveQL. So essentially, Hive is the SQL for Hadoop. If you know SQL, you know Hive. Let's just look at how Hive has changed over the years. As I mentioned, Hive was incubated in Facebook in 2005, 2006. It gained a lot of rapid traction, and in 2010, it was made a top-level Apache project. In 2012, ODBC, JDBC drivers were released, and now you could actually have reporting scenarios, new scenarios like not just ETL, but also BI and reporting scenarios. And then in 2013, Hive introduced Tez, vectorization, and org, and this allowed Hive to be much faster. So with Tez, initially every Hive job would be converted to MapReduce, but with Tez, users had a choice of actually choosing a different execution than MapReduce. So Hive could now run on Tez, which in some cases could be much faster than MapReduce. In addition, with things like vectorization and org, the queries became much faster. In a future session, I'm going to talk about the optimizations with Hive, and we'll look at each of these optimization scenarios. In 2015, Hive introduced ACID, which allows more operational scenarios, like typical SQL operational scenarios. And 2016, in-memory through LLAP, which is a new cluster type in HDInsight called Interactive Hive, which allows Hive to run queries on in-memory data. So the key theme here is Hive is moving more and more towards supporting data warehouse scenarios. It started with batch, moving towards interactive, and more towards OLAP and Cube. This is still where there's active work being done, OLAP and Cube. Right now, we're in this blue phase where work is being done towards sub-second SQL and ACID merge. The eventual goal is to have comprehensive SQL 2011 coverage, to use the advanced cost-based optimizer, and to ultimately replace your data warehouse with Hive. That's the goal. Okay, so we've talked a lot about Hive. Now why don't we look at what you can do with Hive, right? So as I mentioned, Hive SQL, you use Hive SQL. If you've used SQL, you pretty much know Hive, right? So Hive SQL consists of DDL and DML, which allows you to not only create tables, but also run operations on those tables. So pretty much like SQL, you can create tables and you can query data using SQL-like statements. So at this point, I'm going to do a quick demo. I'm going to actually show you how to create an HDInsight cluster and how to quickly use Hive on it. So the first thing I'm going to do is I am going to go to my Azure portal. And this is my Azure portal, and I see that I have two clusters there, Hive Training Batch and Hive Training Interactive. So if I go to Hive Training Batch, and this is a Linux cluster that I've created, I'm going to create a shell. At this point, I'm assuming you already know how to create an HDInsight cluster. If you don't, you can always search online and look up how to do it or see our other videos. I will just point you to a starting place so you know how to create an HDInsight cluster. You just create on plus, new, intelligence and analytics, and here you pick HDInsight, and this is where you can pick your cluster name. So in this case, let me pick Hive training. Let me just do Hive training. I can pick my subscription, and if I choose configure required settings, here are the different types of clusters I can pick. So with that, let's go back to my demo. So once the cluster is created, you have to fill up a lot of things there, like which cluster, what operating system, how many nodes, and then wait about 20 minutes for the cluster to be created. So I already created this cluster, and now what I want to do is I want to try out Hive. So the easiest thing to do is I can actually SSH directly into the cluster. So I clicked on the secure shell, I pressed this button, click to copy, and then I'm going to go to PuTTY. If you have a Mac, you can directly SSH into it, and I'm going to SSH into Hive training batch cluster, and I'm going to hit open, and let's log in. So once I log into my cluster, I am going to run Hive in the command prompt. What does Hive do? Hive actually runs, this is the Hive shell where I can now start running my Hive QL queries. So at this point of time, once the prompt comes, it's very similar to like a SQL, any SQL you've used before. So let's do some basic operations. I'll say show tables, and you can see these are the different tables it has, right? I can do select count star from Hive sample table, and now it's going to run a job. Now again, what it did is it used my when I ran a Hive, this was basically just SQL. So underneath, it converted the SQL query to a test job. It could have also converted to a MapReduce job, but essentially it converted to a mapper and a reducer. And I remember I didn't have to write this map or reduce, it actually converted itself, and it printed the number right here. So you can see, we'll look at this in more details in a few minutes, but I wanted to show you how easy it is to start using Hive. Okay, great. So at this point of time, let's go back to the presentation. What have we looked at? We have looked at, we've got high-level overview of what Hive is. And now let's do a little bit of deep dive on the architecture of Hive. I've already mentioned this in a few places before, but we'll do a deep dive on this. So as I mentioned, Hive is built on Hadoop for data management, querying, and analysis. You access and query data through simple SQL statements called Hive queries. So the way it works is there are different tools you can use to interact with Hive. You can use an ODBC driver, JDBC driver, web interface, command line interface. So we just use SSH, which is a command line interface, and you submit your queries. Underneath, these queries are then compiled, optimized, and executed using a meta store, which in our case is the Azure SQL DB. And then it actually sends these to the Hadoop cluster, to the head nodes and the worker nodes, where it's actually run. So again, the Hive query you sent is compiled, optimized, and executed and sent as a MapReduce or a test job to the Hadoop cluster where it actually runs. So the key thing here is Hive compiles and Hadoop executes. So that's how, at a high level, Hive works. Now, let's go into each of these steps in a little bit more detail. So the user issues a SQL query using a web UI, a command line interface, or a JDBC ODBC driver, and this is sent in the form of a Hive SQL query. Hive takes this and parses this query and plans a query, right? It uses what is called a Hive server 2, which provides ODBC connectivity and also allows the Hive server to submit queries to the underlying application servers, and then it compiles, optimizes, executes, and together with the metastore database. And then it passes on to Hadoop, where it's converted to a Tez job and then executed on Hadoop. So at a high level, this is how Hive works. So you can also, clients also, this is another picture just showing the same thing, but essentially with the driver, Hive driver, clients just submit the job, and the Hive driver takes care of interacting with the metastore, compiling it, and executing it on Hadoop. So there has been a lot of development in the Hive space, and like I mentioned, it has moved from batch to interactive to sub-second, and with that, a lot of new recent optimizations have gone in. Some of them being like from MapReduce, Tez was introduced, and now LLAP was introduced. So today, HDInsight is currently on Hive version 2.0, which offers long-live-in process. It offers vectorization, both text and ORC, a lot of CBO optimizations, and a lot of SQL ACID fixes. So we're currently on Hive version 2.1, but you can go back and see that there has been a consistent innovation in Hive. So this is one of a very innovative fields to make Hive enterprise data warehouse ready. Okay, great. So now let's focus on the next section, is how does Hive compare to relational databases? So if you look at our relational databases and Hive, you can see they're pretty similar, but there are some differences. I think the primary difference is around this first one, which is structure. So when you use a relational database, you actually define the schema before you even write your first line of, you have to first define your schema before you can even write your create tables or store your data, right? So what you do is you have to first think, how are you going to store your data, and then make sure your data aligns with that. So that's how relational data works. On the Hive side, it's actually very different, because in Hive you just store the data, and then when you're creating a table on a data, you define the schema on top. So bottom line is, you can look at the same file and you can create 3 tables. One can be comma separated, one can say the entire string is a row, and then the third one could be tab separated, right? And these could be 3 different tables. So that's very powerful, because with Hive you don't have to think about what data you're storing. You just keep storing your data, and then later on ask Hive to align to it. In terms of access, both use SQL. Indexes, both offer indexing, and this is actually one of a very powerful thing. We will discuss this in our future session on optimizations. Updates, Hive actually recently allowed you to do updates. Locking, you can do both table and partition level locking with Hive. There is no referential integrity with Hive, whereas that is available in relational databases. And finally, there are a lot of query optimizations that are possible with Hive. So these were a few differences. I would say it's more similar than different between the two, which makes it very easy to get your hands dirty with Hive. Okay, now we're going to talk about the last section, which is Hive programming, which is the key of the next few slides of this session. So let's talk a little bit about how, if you were to use Hive to build an enterprise data warehouse, how would you do it? So this is the typical way how our customers do it. I would say typically there are 2 scenarios that customers use Hive for, right? So one is ETL clients and one is BI. What are these 2 scenarios? So in ETL, you typically take raw data and do large complex jobs on it, and make it such that you cook it to produce like a much smaller data, which is then consumed by reporting, by BI users, and things like that, right? So so that's ETL. On the BI side, it's mostly your business users who use Power BI, Tableau, ClickView, things like that, or these can be your reports which are run daily using ODBC, or these can just be data scientists who are running interactive queries. But that's on the BI side. So the way we define how to build a data warehouse is we create 2 clusters. One is a batch Hadoop cluster, and one is a interactive Hive cluster. In the batch Hadoop cluster, the ETL clients will interact with with the engine using either Templeton or Hive Server 2. Templeton is also known as Web HCAT. The goal of Templeton, so why would you choose one or the other? This is actually a conversation we'll have on one of the future sessions, but I just wanted to touch on it briefly. Templeton is great for fire and forget type of job. So if you have a long-running job, you typically want to submit it programmatically and then forget about it, and it'll run and it'll end. Hive Server 2 is great for more interactive scenarios where your session needs to be up while your job is running, otherwise the job will be terminated. So most of our customers prefer Templeton, and they use SDK and PowerShell to connect to Templeton, which can it then send down to the execution engine. So let's understand this a little bit more. ETL clients use the SDK and PowerShell to submit a job to Templeton, which is then compiled and sent to the different application masters, which is created by Tez. The Tez execution engine runs this on Yarn on a bunch of Azure VMs which have been provisioned. Execution engine reads the data from the cloud storage, which can be WASP or ADLS. It can also, I forgot to mention, but Hive Server 2 also talks to the Metastore, which is Azure SQL. So that's how the ETL side works. On the BI side, customers have a lot more choices in terms of tools like JDBC, ODBC, Visual Studio, Hue, and Ambari. And BI clients talk Hive Server 2. Why Hive Server 2? Because most of BI clients are expected to talk within a session. I do want to point out all the tools I mentioned before, JDBC, ODBC, Visual Studio, Hue, and Ambari, can also be used by ETL clients, and of course they will use Hive Server 2. The only downside is, like I mentioned, it's not programmatic way, but it's more interactive way of interacting. So customers still prefer to use SDK and PowerShell and use Templeton to run ETL jobs programmatically. So coming back to BI, so our BI users would use one of these tools to submit a Hive job. It goes to Hive Server 2, which talks to the same Metastore. By the way, this Metastore is shared between these two clusters. So if a table that's created here will be seen here automatically, right? So the output of the ETL job will create a table stored in this Metastore, and once it's done, the BI user will be able to see it. So they can run jobs on this Hive Server 2 using the same Metastore, and underneath it runs the same kind of jobs, except since this is an interactive Hive cluster, it stores 80% of its resources to save memory in cache. So although it uses the same storage account, it also maintains a persistent cache to return queries faster. So to summarize, ETL, you use the Hadoop cluster, which does not have in-memory caching, but it's used for more complex jobs, and customers use Templeton to interact with it. The output of ETL jobs is typically an ORC file, which I will talk about in a future session, which is a more optimized file type. This ORC file is stored in the cloud storage, and a table is created in the Metastore. On the BI, our BI clients will connect a new cluster, brand new different cluster called Interactive Hive Cluster, which will point to the same Metastore that was used for the ETL and same cloud storage account which was used for this ETL, so that they're able to see the queries, the tables, and the data that was created here. Next, the BI clients will use the JDBC, ODBC, Visual Studio, Hue, and Ambari to read from tables, to run queries on the tables, and the data will actually be read from the cloud storage. However, if it is in ORC format, it is cached in memory, so that the subsequent queries which are similar do not have to go to the storage account, but or on disk. It can just be run directly from in memory. So this is how typically customers build an enterprise data warehouse using Hive. So I hope that was a lot of words. Hopefully that made sense. If not, we'll talk about it throughout the session. Okay. Now that we've talked about how to build an enterprise data warehouse, let's see what are the different ways of running tools. So we have different authoring tools to run Hive jobs. I've actually already shown you one. which is SSH, right, which is right here. You can log into the cluster and run your jobs here, but there are more easy ways to do it. Probably the easiest way is if you go back to your cluster right here and click on Ambari views, it will bring up the, let me do it again. If I click here, it brings up credentials that I'll need to enter, so let me enter that. But at this point of time, it brings up what is called an Ambari Hive view. So if I click on Hive view, this is a great graphical interface to run Hive queries. So for example, I can type the same queries here, select count star from Hive sample table. I type this query and I hit execute, and it will submit the same job to the cluster, but it's a more graphical view where I can see the results. I can actually debug my queries right here, and I will show you how to do that. But Ambari Hive views is a great way of running your jobs in a more graphic, if you prefer GUI. So you can see the job ran. I got my results also, about 60,000. If I want to see more information on this, I have history. I can go look up the history, and this is a few minutes ago. This is the query that I just ran. I can upload a table. So if I pick a table here, it will create a table out of the query. I can also, if I want, I can look at there is no DAG available because this was a pretty easy query, but it shows me a visual explain of exactly what it did. So there was a mapper and a reducer. So a lot of different and neat features that are available using Ambari views. So that's one. I've also talked about command line. The next one I'm going to talk about is Visual Studio. So we've also done Visual Studio integration. So let me open Visual Studio. So if you have Visual Studio, you can actually install our Hive ODBC driver extension. It's available online if you just search for it. And then if you log in with your Azure credentials, it'll automatically bring all your Azure resources here. So if I click on HDInsight, it'll actually show me all the different cluster types that I have for my subscription over here. So let me do File, New Project, because what I want to do is run a Hive job. So I will do a File, New Project and click on Hive Sample and click OK. And now at this point of time, it's going to bring up my Hive. This is just a Hive sample code. Let's look at what it's doing. So it's just, first thing I want you to realize is it's just like SQL. And secondly, you can look, you can drop the table web logs. It's creating a table, external table, and we'll talk about what external table is, but I just want to show you how this works. So essentially, it's creating a table. It's saying it's delimited by space, and it's saying it's located at this location. By the way, this query you can run yourself if you just download this Visual Studio extension and do a sample job. And then it's creating another table called client errors, and it's terminated by a comma. And finally, it's populating it to another table. So it's doing a bunch of operations. So at this point of time, I want to run it. So I am going to pick, my cluster. So I'm going to pick the same cluster, which is called it's called Hive Training Batch, right? If I remember, let's go find it. I think I saw it here, Hive Training Batch right here, right? Now, once I picked Hive Training Batch, I have a couple of options. I can either submit it using Templeton, or I can execute via Hive Server 2. If you guys forgot what that is, I can, again, since this is a Hadoop cluster, batch cluster, I can either submit using Templeton or using Hive Server 2. Because this is Visual Studio, it can use either. So I will choose using Hive Server 2 because it's faster. The reason it's faster is because it uses Hive Server 2. Typically, Hive Server 2 we'll talk about in a future session, but it uses what is called an application master, which makes queries run faster. So once I hit execute, it's actually running this job. You can see it's spun up a few map under reduced jobs, and it's actually loading this data and streaming. It's doing its thing. It'll take a few minutes. Not sure what. I think this is not related to this job. It's some other exception. So I just hit OK for now. But it says all Hive queries are executed successfully. So this is an example of how we use Visual Studio to run jobs. So I've shown you how to use Ambari views, I've shown you how to use Visual Studio, and I've shown you how to use command line. The last option is to run Beeline. What is Beeline? Beeline is another tool, which command line shell, which is much lighter than like SSH, than the Hive shell, and it works very well with Hive server too. So let's go back here. If I want to use Beeline, I can just log into my head node and run this command, and at this point of time, I can just run basic queries like select count star from Hive sample table, and it's basically going to do the same thing where it'll run a Hive job, underneath is a MapReduce job, and it'll show me the output. So we'll give it a second to start. One of the things you would notice is when you run your first job, it takes a few seconds because it's creating a session, but subsequent jobs will be very fast because it's already created the session up. You can see the second job was much faster. Okay, great. So we talked about the different authoring tools. Now let's talk about creating tables. So Hive has two kinds of tables, external tables and an internal table. What is the difference? An external table says that the data should be stored in HDFS, whereas for internal table, it's not. While it's still stored in HDFS, it's stored in its Scratch directory. So the key difference is if you drop an external table, while the table metadata information is dropped, the storage, the data of the table is still stored. But if you drop an internal table, the data and metadata both are lost. So so choose wisely. I always go towards external table. I always go towards external table because in case you drop the table, you still have the data available, right? So that's the difference between an external and an internal table. Other than that, Hive provides the same functionalities that's available in SQL. So again, typically most of the things you find in SQL you will have in Hive. Insert, select, where, group by, order by, join. Why don't we go try a few things so again, I'm in my Beeline, and I will say select count star. Actually, let me do this. Let me first describe this table. So I say describe Hive sample table. What this does is it shows me the different columns. Then I'm going to say select star from Hive sample table limit 10. So what I'm doing is I'm just printing the first 10 rows. So now I know that one of the states is Colorado. So now I'm going to say select count state, comma count star from Hive sample table group by state. So what I'm asking Hive to do is in this table, which is a collection of phone records, it seems, just by looking at the data, I'm asking it to do a count star for each state and then print like the state and how many phones or devices were in that state. Now it did print something, but it's too much for me to read, so I will do order by order descending, right? So now hang on. So order by I will say actually order by state descending. So while I could go and do order by count star, and that's what I want to do, I'll have to go and change this query to say count star as. So in this case, I will just order by state. So I'll put it in descending order of the state. So again, the goal of this is just to show you that you can run, like you can pretty much use any SQL operation in Hive. Okay. So I guess one of the key, so we've talked about Hive and its power and how similar it is to SQL. One of the key addition things that you can do with Hive and why it's so, one of the key additional things what you can do with Hive and why it's so much more popular is you can actually run your user code in Hive. So Hive allows you to run Java code or Python code and extend SQL functionality into your own logic and bring it into the query. So now next couple of demos, we're going to see how that works. So let's go back. As I mentioned, there are two ways of calling user code in Hive, using Java and using Python, and we're going to look at both. So let's start by looking at using Java UDFs, and our goal is to see how we can parse JSON using Hive UDFs. So the reason, by the way, I'm picking this is one of the most common requests, because most of the data today is using JSON, and Hive allows you to process JSON. By the way, whatever I'm going to do here is available on the internet. I have written a blog post about it, and if you'd like to see it, just go to Bing or Google. Let me just go to bing.com and I just say Hive JSON. And if I search for it, this first couple links will take you to this. So what we're going to do in this operation is, I have a JSON file, and let me actually show you. Let me open Cloud Explorer. What is Cloud Explorer? Cloud Explorer is a Windows Explorer for Cloud Explorer is Windows Explorer for your Azure storage account. So the reason I'm opening this is I want to show you a file that I have in my storage account. So in my Rashimji storage, I have a Hive training batch folder, and I have a JSON folder, and I have a students folder. Out here, if I open this text file, okay, you can see this is essentially a JSON file with a record of a student, what the student ID is, what the grade is, what their name is, things like that, and what the class participation is, score is. So for the different classes, what their score is. So that's what I have in JSON, and my goal is to run some queries on this and see if I can use SQL queries on this JSON data. That's what we're going to do. How are we going to do it? So we are going to get first a user code written by a third-party user code. You can also write your own. In this particular case, I'm just going to use a very popular one, the Hive JSON Survey. It is, and I will show you where to get it. Once we download the source code, we will build it, and then we will use it in Hive. So before, how do I do that? So if I just, again, if you just go back to this blog, there's a link to the survey I downloaded, and we're going to go find it right here. This is the survey that I have, and I will download it. So once you do clone or download, it'll download it. You can then upload it to the cluster. I've actually already done that, so let me exit out. So it's right here. Firstly, let me just do, so what I'm doing is I've already created it, so I'm just deleting it. I've already unzipped the file, so I want to show you starting from scratch. So what did I do? I just did clone or download, and I downloaded the zip file, and this is the zip file that I've downloaded. Okay, so at this point of time, I looked at a user code which was written by a third party, Roberto Congui. He or she wrote this survey, which is user code. I downloaded the zip file to my cluster, and then the first thing I'm going to do is unzip it, right? So I will do unzip json.zip, and I see that a new folder was created, Hive JSON survey. Then I'm going to go to this survey, and I'm going to build it. So I'm going to say mvn package, and what this allows it to, what this tells, this asks Maven to build this package so I can start using it. So once I've built it, I see there is a target folder. I go to the target folder, and there is a jar already created, and this is the jar that I want to use, right? So next thing that I'm going to do is I'm going to open the Hive command prompt. So let's take a step back. I downloaded the zip, I built the zip, created a jar file, and then I opened Hive, and at the Hive command prompt, I'm going to say add this jar file, right? Because now I'm adding the Java code. So I'm going to say add jar, which is a special Hive syntax to add the Java user code. So now it's added the jar. And now I can call different methods in this jar, for example. And if you follow the instructions here, he's going to explain what the different methods are you can call. I'm going to just, for the sake of this demo, I'm going to move on ahead. And at this point of time, I'm going to create a table. What is this table doing? Let's look at this a little bit in more details, and then we can go back. So what it is doing is this. It's telling, first things first, it's telling Hive to look at this survey which I just added, right? So I just added a survey. It's called JSON survey by OpenX. So it's telling Hive, go read this survey, and then it's saying read the JSON which is in this folder, JSON students, and I opened it for you. And then it's creating an external table, JSON table, using some special custom code, which the JSON survey explains how to use it. And essentially what it's doing is it's defining a schema of the JSON and putting it in Hive format. So it's just saying create an external table, JSON table, where, and then it's just listed the schema of the JSON such that Hive can understand it. So I'm going to do this next. I'm just going to run it. I go back here, I run it, and at this point of time, it's created this JSON table using the survey and using the data from the JSON students table. And now the great thing is I can run it. So now let's say I want to select the first name and last name of a student. I can just run this query from this JSON table. Remember, again, if you remember, it was just a JSON, and you cannot run Hive queries directly on JSON. But using the survey, I can now run SQL or Hive queries on JSON as easily as it were SQL. So let me also do select sum of all the scores of all the courses that this student took, right? And when I do it, I use something called as lateral view, which is another user view. Use UDF in Hive. You can look it up, but it's able to do that. So this is how easy it is to add your own custom code and extend Hive and then run your queries on it. So that was Java. I'm going to show you the same thing with Python. So using the Python UDS, you can actually, you can also add Python. So what are we going to do? Let's go back to my Cloud Explorer, and I see that there's another folder called py, and it has this code for streaming py, and I'm going to just open it to show you. So it's a typical Python script which is reading from the input, standard input, and it's removing the new line character, and then it's reading the client ID, device make, and device model, which is split by tab, and then it's just doing a join. So again, what's more important is how to use it. So this is a Python file that I have in my storage account under py/streaming.py, right? So if I were to use this in my Hive script, how would I do it? So a couple of things. Firstly, Python 2.7.6 is already installed in your HDInsight cluster. So you can just use one of the UDF, sorry, there's a typo here, UDF in Hive called transform, and you can ask it to run this Python script. So how do we do that? Again, this is the Python script that I just showed you. I will tell Hive to go pick up, just like I said, add jar. I will tell Hive to pick up this Python file from my storage account, and then I will say select transform whatever the columns that will be transformed by the Python script, and I'll provide the Python script name, and I will run it. So let me try this. So I'm going to go back here, and I added the file and I'm running it. And again, you can see it's running the Hive job. It's for each row, it's going to call that Python code, and it produced the output as directed by the Python script. So that's an example of how I used Python in my Hive script. So I'm going to show you one last thing, which is using the Hive ODBC driver. So Hive does, HDInsight does have an ODBC driver which comes, which you can use to configure your BI tools and run it in Excel, Tableau, Power BI, whatever you like. And I'm going to show you how to do that. So once you just go again on the internet and search for Hive HDInsight Hive ODBC driver, and you can click on this link and you can download the driver. Once it's downloaded, let me show you. You can go to ODBC data sources and configure your Hive driver. So in this particular case, I can actually define which my host name is, what my username is, what my password is, and then I can just run it. So let's go try this real quick. I'm going to open Excel, and I'm going to say data from, so I'm going to say data, and I see there's already a connection, but I will say from new query from other sources, and I'm going to say from, let's see, give me 1 second here. So the connections. Okay, so I will say data, get external data. I think I hit the wrong button here. Okay, so let's say data from other sources, and I'm going to say, I think it's from ODBC. I'm going to say Hive driver. I hit OK. And at this point of time, it is asking me to, I think I'm looking at the wrong place. Let me try another place. So data from other sources, and I'm going to say from blank query. Is that where it goes? No, that's not it either. Okay, let's try this one more time. I think I just did this a minute ago. Something is not right. So I'll open Excel again. Okay, and I will go to data, and usually there's a button here. Is it get from other sources from Microsoft query? There you go. That's what I was looking at. So I went to get external data from other sources, and here I will pick Hive driver. I hit OK. Actually, let's click on options, and I hit OK. And this is where it will bring up the Hive ODBC driver connection. So, and I will just say it's called Hive training batch, right? Let's go back to my cluster type. It's called Hive training batch. So let me do it. Let me actually, I don't think, so Hive training batch.azure.hdinsight.net, and I'm going to put my admin and the password, Qualcomm, and I'm going to hit test. So at this point of time, I gave it my cluster name, my username, and my password, and it's going to test, and it says it was successful. So I'm going to hit OK and go back here. So now it's going to connect to, it says connecting to the database source, and so at this point of time, it's actually connecting to the data source, and it's saw all my table. So I'm going to pick Hive sample table, and let's say columns in your query. Let's say I open it, and I just say let me do the same thing. Let me get the state, and I hit next. And I will say only include rows, state. Actually, I'll just hit next, finish, and it's at this point of time it's actually returning the data to Microsoft Excel. So at this point of time, it's running the query in the Hadoop cluster and bringing the data back to Excel. So let me go back here, and I hit OK. You can see it's saying waiting for the query to be executed. So it's actually running it on the cluster, and then it will bring the results back to Excel. So, so you can use this to connect to Tableau, to ClickView, to Power BI, basically anything that connects with our ODBC driver. This driver also works with both the batch Hadoop cluster and the interactive Hive cluster. So there you go. There is the answer where it got all the results back to Excel, and now you can do Power Pivot, Pivot Table, or whatever you'd like. Okay, so great. So I also showed you how to analyze your data in Excel. So now you're ready to get started. You can just search for HDInsight on the web, or go to that URL. You can also check out more of our videos on Channel 9, on YouTube, and try out HDInsight to make your Hadoop experience very easy. Great, thank you very much, and look forward to connecting with you in more videos.